Alright, here we go with the next part, free response area of the practice test. So question 1 is to balance some chemical reactions. Turns out that you're going to need a 2 in front of this to get you an even number of chlorines, which means you need a 3 here, which means you need a 2 here. For this one, it's 1, 1, 1, and then you need a 2 here for the KCl's. In this one, it goes 1, 2, 1, and 1. And then for the last one, it's just 1, 1, 1, and 1, and you're all balanced up. Those are the balanced chemical reactions. Question number 2, calculate the percent makeup of several different things. So first of all, the C2H6O, remember to find percentage composition, it's always part divided by whole times 100%. And so we want to know carbon, hydrogen, and oxygen. So the first one we'll do is percent oxygen. And so for oxygen, look up oxygen on the periodic table at 16, and then add up everything on the bottom. And if you add up C2, that'd be 12 times 2, plus hydrogen, which is 1 each, or 6, and oxygen 16. I believe that whole thing adds up to 46. Multiply that by 100, and then you end up with 34.7%. That's oxygen. Then to do the percent that's carbon, we would do 12 times 2, because there's 2 carbons in there, divided by 46, the whole thing, times 100% again, and that would end up being 52%. And then the last one is the percent hydrogen, and hydrogen in this would be 6, because there's 6 hydrogens, and 6 times 1 is 6, divided by 46 times 100%, and then it ends up being 13% of the hydrogen. The CH4O, for that one, I'm going to zoom in on this work right here because I already did this one. Here's CH4O, the carbon percent, the hydrogen percent, and the oxygen percent right here. So remember, part divided by whole times 100% gives you the percentage of the compounds portion. Number 3, this is a stoichiometry type problem now. We have silver nitrate reacting with zinc metal to make a metallic silver. Calculate the mass in grams of silver made with 20 grams of zinc nitrate. So the steps for stoichiometry are: number 1, write the balanced equation. That's done. Number 2, take your 20 grams of zinc and convert it to moles. So put grams in a position where it's going to cancel. Moles is your new set of units. For zinc, it's 65.4 on the periodic table. You can look that up on here, and you'll find it right above the zinc as 65.4. That's in 1 mole of zinc. Then step 3, use the mole-to-mole ratio. So putting zinc in a position where it's going to cancel, and silver as your new set of units. For every 2 silvers, right here, there's 1 zinc. And then lastly, it asks for the mass, so step 4 is to convert to the asked for unit, so we've got to convert to grams of silver. So grams of silver goes here, moles of silver goes down here, and in 1 mole of silver there's 107.9 or 108 grams. Multiplying those all together, you get pretty close to 65.99 grams of silver. Good, straightforward stoichiometry problem. Here's the second one. Calculate the mass of aluminum chloride produced if 27 grams of aluminum react with excess chlorine gas. So for this one, I'm just going to zoom in on my work right here, and I'll talk through it. So here's the 27 grams of aluminum. Well, first of all, a balanced chemical equation is right up here, so that's done. Step number 2, convert to moles. Here's the conversion of moles right here. Step number 3, multiply by the mole-to-mole ratio. So the mole-to-mole ratio is 2 to 2. For every 2 aluminums, there's 2 aluminum chlorides. And then step 3, convert to the asked for units, and it wants to go to aluminum chloride grams. In 1 mole of that, it's 133.5, so you end up with 133.5 grams. All right. Next, we're going into problem number 4 right here, where it asks about sodium carbonate is used to standardize hydrochloric acid solution in the following titration reaction. We have a balanced chemical reaction right here. So step number 1, balance the chemical reaction. Step number 2, convert it to moles. So we'll take our 2.5 grams and convert that to moles. So grams in a position where it's going to cancel. Moles is our new set of units. And then in 1 mole, there's 106 grams. I added sodium carbonate up on the periodic table. And then step number 3, putting sodium carbonate in a position where it's going to cancel, and then go to my new set of mole units that I want to know. And I want to know hydrochloric acid, so put that on the top. And for every 2 hydrochloric acids, there's 1 sodium carbonate. And then lastly, it just asks for moles right here, so you're actually done. You don't have to do step 4. So 2.5 divided by 106 times 2 ends up being 0.0472 moles of the hydrochloric acid that are needed to react with it. And then letter B, the titration required 19 milliliters of hydrochloric acid to reach the end point. What is the molar concentration? So for this one, now that it took 19 milliliters, we know that we want to find the concentration. So the concentration, remember, is molarity, and molarity equals moles divided by liters. So here's my moles that it took, and then I'll take that number and divide it by my liters. And remember, 3 to the left, 1, 2, 3, so 0.019 liters. Divide those 2 animals by each other, and you end up with 2.48 molarity. All right, the next problem is one that says this problem is more difficult than any on the exam. You can do it. You'll certainly do well. And I'm going to talk through that one right now. I have the work already written out. And I'm going to talk through the step-by-step process of doing it. I won't write all the work, but I already have it written down here, and I'll talk through it. So it says that lead 2 nitrate is mixed with sodium bromide, and so step number 1 is to write the balanced chemical equation. So here's the balanced chemical equation of those taking place. I'm going to zoom in on it just a little bit more and move the problem, because you can always look up the problem on your own paper. And then it says letter B, which is the limiting reactant. So we're going to have to convert both things to moles, because we were given 33 grams and we're given a volume and a molarity over here. So 2 things to convert to moles. So here's my 33 grams of lead nitrate. There's 331 grams in a mole when you add up lead nitrate on the periodic table. So you have 0.1 moles of lead nitrate. And then using the molarity triangle, I convert to moles of NaBr, so I end up with 0.1 moles of that as well. Now, to determine which one limits, remember you have to divide by the coefficient. And so if I divide lead nitrate, I would divide that by 1, and I would divide sodium bromide by 2. And remember, you don't actually have to do the math, just decide which one's going to be smaller, and 0.1 divided by 2 is obviously smaller than 0.1 divided by 1. So NaBr is my limiter, which answers letter B, which is a limiting reactant. Letter C, what are the concentration of all ions that remain in solution after the reaction is complete? Make sure to circle your final answers. So now we end up with 3 different stoichiometry problems to do, because we know that sodium bromide limits, so there'll be none of this left at the end. But there will be some of this left over, there'll be some of this produced, and some of this produced right here. So let's walk them through one by one. I'm going to take the sodium bromide, my limiter, and always start with that, and I'll compare it to the lead nitrate right here, a 1:2 ratio. So that's my mole to mole ratio right here. So then I find out how much lead nitrate was used. I know I started with this much lead nitrate, so I find the difference between those two, and the word difference in math class means subtract. So subtract 0.05 from 0.1, and that means I would end up with 0.05 moles of this remaining. It says the concentration of all solutions, so I need to divide it by my total number of liters, which is 0.5. So then it ends up being 0.05 divided by 0.5, which is 0.1 molarity. Now, if I wanted the ions in the solution, I'd have to break that up, because that's a soluble species, and so nitrate, there'd be twice as much, because there's a 2 right there, so it'd be 0.2 molar in nitrate, it would be 0.1 molar in lead. Okay, so that takes care of one of them. Now I have to go do a similar thing for the sodium nitrate and the lead bromide over here. So let's do the sodium bromide as my limiter once again, and then I'd go to sodium nitrate, and sodium bromide. So there's my mole to mole ratio, step number 3 right here, mole to mole ratio. And then after I multiply by my mole to mole ratio, I find out how much sodium nitrate is produced. I take that number of moles and I have to use the molarity triangle to convert to the asked for units, and asked for units